Okay, we're now going to look at drawing graphs that are where the modulus is within the function. Okay, so something like this: y equals sine of modulus x. So in the previous video we've looked at y equals the modulus of sine x. We're now looking at what happens whenever the modulus is inside of the function. Okay, so let's first of all just consider the y equals sine x graph. So this is y equals sine x. So we've put in values, positive values, and you get this graph. And then you put this shape of graph, and then you put in the negative values and you get this side. Now, whenever you do modulus within inside of a function, remember what that does is it makes all the values positive. So if you put in 1, then the answer is 1. If you put in 2, the answer is 2. If you put in 3, the answer is 3. So like for instance, if you had modulus of x, if you put in 1, the answer is 1. You put in 2, the answer is 2. You put in 3, the answer is 3. If you put in minus 1, the answer is 1. If you put in 2 or minus 2, the answer is 2. If you put in minus 3, the answer is 3. So the modulus function has the effect of making all the negative values positive. So whenever you consider the graph, okay, what's happening is you're going to put a value in here, you're going to do the modulus, and then you're going to do the sine of it. So for instance, if I was doing the sine of 90, remember the sine of 90 is 1. What you're going to do, if you're going to do this, which is the sine of modulus x, well, if you put in 90, you get the modulus of 90, which is 90, and the sine of 90, which is 1. So the positive side, it has no effect. The positive side on this graph will always remain the same. Now let's consider the negative side. Let's consider negative 90, okay? So the sine of negative 90 is minus 1, normally. Let's consider it for this graph. So if you put negative 90 into here, the modulus of negative 90 is 90. And then the sine of 90 is 1, as we've seen from before. So this will have the effect, having the modulus within inside of the function, will have the effect of reflecting the positive side into the negative side. Okay? So whenever you're drawing the function with the modulus within inside of it, what the steps are: step 1, draw f of x for x is bigger than or equal to 0. So in other words, you draw the positive side of the graph first of all, okay? So you start at 0 and you draw the graph the whole way across this way. Step 2, reflect in the y-axis. So you reflect this side over here. So if I wanted to draw this graph, if I want to draw this graph, y equals modulus sine, y equals sine of modulus x, I would draw my axes, I would draw the positive side, which looks something like that, and then reflect it, so my graph would look something like that overall, okay? So this is the graph y equals sine of modulus x. Let's look at another example. Okay, so we're going to draw the graph y equals 2 to the modulus x. You can see here the modulus is within the function, so it's not the y equals the modulus of 2 to the x, it's y equals 2 to the modulus x. So what we're going to do is we're going to draw the graph, first of all, of 2 to the x, okay, as normal. Okay, so 2 to the x, so 2 to the 0 is 1, anything to the 0 is 1, and then 2 to the 1 is 2, 2 to the 2 is 4. Remember, it's your exponential graph, it's going to look something like that, okay? So remember, for this graph, you draw the positive side first of all, like that, and then you're going to reflect it into the other side of the y-axis. So what would happen is the graph would look something like that. Okay, well, reflected properly, not like this on a whiteboard.